All right. We are ready to start. Somebody needs to confirm if the screen is visible.
Yes, sir.
Okay, thank you. Okay, so we'll continue from where we left off. We're talking about random processes, and in the last week, we saw a few examples of random processes, some important random processes. We talked about a random walk process, Random walk process क्या था? Random walk process was at every step, at every instant of time, and the time is discrete here, at every instant of time, you either gain +1 or you lose +1. You lose 1 or you gain 1. Okay, तो यूं समझ लें कि 0 से अगर start किया, so you will move to the right 1 unit or move to the left 1 unit. With some probability you will move to the right. Generally this probability is 1/2. So किसी probability से आप right पे चले जाएंगे, किसी probability से left पे चले जाएंगे. So and you will continue doing this. So let's say at a certain point in time you are standing at a position which is 8 units to the right of the starting position. 8 units to the right. तो अब वो 8 units से अब आप एक या left जा सकते हैं या एक right जा सकते हैं. So यानी या तो 9 right पे चले हो जाएंगे या 7 right पे हो जाएंगे. So we talked about the random walk process. And we showed that the random walk process is an independent increment process. Independent increment process. And independent increment process is a bigger class of random processes, and random walk is a subset of the independent increment process. And the independent increment processes are a subset of what we call Markov processes. And Markov processes are those in which the future and past are independent if the present is given. The future and past are independent if the present is given. Okay. Now, it is entirely possible कि when I say कि present is given, कि आपको एक time के ऊपर जो है वो random process बता दिया जाए कि क्या है, एक specific time के ऊपर, और future और past independent हो जाए. लेकिन present को it is not entirely required that the present has to be one specific time instant. ऐसे भी हो सकता है कि आपको 3 time instants के ऊपर बता दिया जाए, n is equal to 3, n is equal to 4, n is equal to 5, where n is time, discrete time. 3, 4, 5 के ऊपर आपको random process बता दें और फिर 5 से आगे वाले और 3 से पीछे वाले ये independent हो जाएं. So that's also Markovity. That's also Markovity. So Markov processes, if present is given, future and past will become independent. Then we also had talked about Iid processes, independent identically distributed processes. That a random process is, whenever you look at the random process at a specific time, you will get one random variable. किसी भी random process को एक specific time के ऊपर look करेंगे, so you will get one random variable. If all of those random variables that you have in the random process, if all of those random variables are independent, identically distributed, that's an Iid process. That's the Iid process. Okay. So I'm not going to go into the details of these, which have been covered in the last week. Today we will talk about the mean and autocorrelation function and some additional random processes. Specifically, we will talk about the Poisson random process, and maybe if time permitting, we will talk about the Gaussian random processes. Okay. We talked about the mean and autocorrelation function. So mean of a random process xt, mx of t, mean is a function of time. Mean is a function of time. Why? Because if you look at the random process, it is this function and this function and this function and this function. Yes, in सारे functions की जो है वो collection है. If you look at the random process at any particular instant of time, किसी एक खास time के ऊपर देखते हैं, इस time के ऊपर देख लेते हैं. So you get either this value or this value or this value or this value, because these values are coming from कहां से आ रही हैं ये? सैंपल स्पेस से. You did an experiment and उस एक्सपेरिमेंट की 4 आउटकम्स थी, मुझे पता नहीं है 4 में से कौन सी आएगी. इट कुड बी एनी वन ऑफ दीज. जब एक आउटकम आ गई तो आपने एक सैंपल फंक्शन डिफाइन कर दिया, वो इन 4 ब्लैक लाइंस में से. दिस इज वन सैंपल फंक्शन, दिस इज वन सैंपल फंक्शन. So you will get at t is equal to t1, you will get one random variable. At t is equal to t2, अगर t2 पे देखें तो आपके पास ये वैल्यू आएगी, ये वैल्यू आएगी, ये वैल्यू, ये वैल्यू. So which is yet another random variable. The mean is defined as is also a function of time. ये जो आपके पास एक random variable आ गया, इसका mean निकाल लें. फिर एक ये random variable है, इसका mean निकाल लें. हर टाइम के ऊपर एक random variable है, mean निकालते जाएं. So you will get the mean as a function of time. This is expected value of x of t. We had also defined autocorrelation function of the random process, which is Rx computed at 2 times t1 t2, and we said that Rx t1 t2 is expected value of 2 random variables multiplied together. Xt1 is one random variable, xt2 is yet another random variable. xt1 कौन सा random variable है? वो ये वाला random variable है. This random variable is xt1 and xt2 is this random variable. xt2 is this random variable, and we have been calculating expected value of x times y. दो random variables की product की expected value हमने बेशुमार दफा निकाली है. What we will need to find the expected value of the product of these two guys is their joint distribution. हमें इनकी joint distribution चाहिए होगी. Generally it is known, या हम निकाल लेंगे उसको. So this is called the autocorrelation function. Then we had also defined autocovariance function, which is cx t1 t2, which was simply rx t1 t2 minus mx t1 mx t2, mx t1 mx t2. We had also defined a wide sense stationary process. Wide sense stationary process के लिए there are 2 requirements. One requirement is that mxt is constant. It should not change with time. So Iid process is automatically has a mean which is constant. Why? Because at any instant in time, whatever random variable you have, it is independent, identically distributed. Identically distributed means कि सबका mean same आएगा. Okay. The other requirement for the wide sense stationary process is कि Rx t1 t2 is a function of t1 minus t2 or t2 minus t1, whatever you like. Okay. Is a function of t1 minus t2. This implies that we can talk about the variance of these random variables. जो एक टाइम को फिक्स करने से जो मुझे random process नजर आता है, we will talk about the variance of x of t. Yeah. These two imply कि variance of the random process, this becomes constant. Variance हमने कैसे define की है x of t की? Variance हमने ऐसे define की है. Now we don't talk about 2 different times. So variance of x t1 is equal to simply cx t1 t1. दोनों times जो है t1 और t2 और एक ही आपने random variable ले लिया. So instead of talking about 2 random variables, you are talking about the expected value of the product of 2 random variables minus the product of the expected value of those 2 random variables. So this is really equal to expected value of x t1 minus expected value of x t1 whole square. X t1 multiplied by x t1 है, ठीक है, ये mx t1 mx t2. So t2 की जगह पे भी t1 डाल दिया आपने, which is really expected value of x t1 whole square minus expected value of x t1 whole square. और यही तो variance की definition थी, ठीक है. Now for the variance what we are saying is कि variance should be independent of time. So variance of xt2 अगर आप निकालेंगे वो भी सेम आ जाएगी आपके पास, वो भी सेम आ जाएगी. And why is that? This is because rx t1 t2 is a function of time. So इसका मतलब है कि this is a function of t1 minus t2. जब t1 को t2 के इक्वल डालेंगे वहां पे तो इसका मतलब है कि वहां पे जीरो आ जाएगा. t1 t2 की टर्म जो है वहां से सारी खत्म हो जाएंगी, सब खत्म हो जाएंगी. ओके. एंड देन this guy here, expected value of xt1 square, this is mean का square and mean is constant already. तो ये वाली टर्म भी कांस्टेंट हो गई है और ये वाली भी टर्म जो है इसमें t1 और t2 नहीं आ रहे हैं. Why? Because t1 minus t2 का फंक्शन था, t1 को t2 के इक्वल डाला तो वो उसमें से t1 t2 दोनों निकल जाएंगे. Okay, so what you will get is same value. This is for the wide sense stationary random process. Wide sense stationary random process. So today I'm going to find out the mean and autocorrelation function of some example random processes. Last time we talked about the Iid process. We talked about the random walk process, independent increment process, and Markov process. So let me just give you an example of how to go about finding the mean and autocorrelation function. When you find the mean and autocorrelation function, you can automatically find the autocovariance function and the variance as well. So mean and autocorrelation function of some examples random processes. Example random processes. सबसे पहले let's consider the Iid case. Iid random process. So Iid random process में x1, x2 ... are Iid independent, identically distributed. Let's assume each with mean mu, each with mean mu and variance sigma square, each with mean mu and variance sigma square. So let's try to find out the mean of the random process. ये तो मैंने mu और sigma square जो बताई हैं ये each x का बताए हैं. So xi has mean mu and variance sigma square. Some PDF or PMF. Now let's try to find out the mean of the random process. Mx of, instead of t, let me just put n here. T भी लिख सकते हैं, but typically we use t for continuous time and n for discrete time, although it is not a requirement, but generally जो है वो books में भी अगर आप देखेंगे n को use करते हैं discrete time के लिए, t को use करते हैं continuous time के लिए, although I can use either. I can use t here as well. Okay, so mxn is basically expected value of xn, which is इनमें से कोई सा भी कंसिडर कर लें, x1, x2, x3, सबका मीन म्यू है because they are identically distributed, so everyone has the same distribution. So answer is mu. This is constant. Very good. Okay. So now let's find the rx t1 t2 की जगह n1 n2 इसको कर देते हैं rx n1 n2, which is expected value of xn1 xn2, which is equal to, now there are two cases to consider here. First case is n1 can be equal to n2, and n1 can be different from n2. और इन दोनों केसेस को जरा अलग-अलग कंसीडर करना पड़ेगा. You will see the reason why. So this is equal to expected value of, when n1 is equal to n2, this is simply x of n1 whole square, which is equal to, क्या होगा ये? Well, if you recall, हमारे पास एक relationship था, variance of x was equal to expected value of x square minus expected value of x whole square, right? ये तो सबको पता है. सही, इसमें से हम निकाल सकते हैं expected value of x square. कैसे निकालेंगे? तो वो आपके पास expected value of, sorry, not this guy, but this guy, expected value of x square. So this looks like this, the expected value of xn1 square. So this is simply equal to variance of x plus expected value of x का square. इसको उधर लेके चले जाएंगे. So this is equal to variance of xn1 square, which is sigma square, plus the means of that, which is this guy. Okay. And when xn1 is not equal to xn2, okay, so then this guy would be equal to expected value of xn1, expected value of xn2. Why can I write this? Because n1 and n2 के ऊपर जो दो random variable हैं xn1, xn2, they are independent of each other unless n1 is equal to n2. n1 is equal to n2 आ जाए तो फिर तो independent नहीं हो सकते, obviously, then both of those are same. So this is equal to simply mu square. This is mu square. क्योंकि दोनों टाइम के ऊपर n1 के ऊपर भी मीन जो है वो mu है, n2 के ऊपर भी मीन mu है. So Rx n1 n2 is this guy or this guy, either this or this. Is this a function of t1 minus t2 or n1 minus n2 in this case? Is this a function of n1 minus n2? No or yes? No or yes? Are these guys the function of n1 minus n2? Yes or no? Yes, they are function of n1 minus n2. They are function. क्योंकि इसमें मैं 0 times n1 minus n2 add कर दूं, तो this will be a function of. So that means कि IID processes are wide sense stationary processes. All IID processes are wide sense stationary processes. In fact, IID processes are also strict sense stationary random processes. हम strict sense stationary की बात नहीं कर रहे हैं इस कोर्स के अंदर. Strict sense stationary are they have more requirements. So they are definitely wide sense stationary, plus they are some more. I'm not going to go into the details of strict sense stationarity. Not very useful from a practical standpoint. From a practical standpoint, wide sense stationary processes are very useful. ये बहुत जगह engineering में, computer science में बहुत जगह पे इस्तेमाल होती है. So I'm going to do another example. This example is random phase sinusoid. We did this example last time as well. Okay, x of t is equal to small a, which is constant, cosine omega t plus theta, and this theta is a random variable. This theta is a uniform between 0 and 2 pi. Could be uniform between minus pi and pi, would be the same answer. Now I'm interested in finding the mean and autocorrelation function of x of t. What is the mean of x of t? Mean of x of t is equal to, now this is a function of theta. If this is a function of theta, how do you find the expected value of a function of a random variable? Well, to find the expected value of a function of random variable, you integrate it over the range of the random variable. Over the range of the random variable 0 to 2 pi, okay, e times cosine omega t plus small theta, which is not a random variable, deterministic number. It could be anything from 0 to 2 pi, into the PDF of theta. What is the PDF of theta? PDF of theta is 1 over 2 pi, because ये 0 से 2 pi तक uniform है, 0 से 2 pi तक uniform है. So the height of this guy has to be 1 over 2 pi. Why it has to be 1 over 2 pi? क्योंकि PDF है, इसके अंदर area under the curve जो है वो 1 होना चाहिए आपके पास, ठीक है? So this would be 1 over 2 pi d theta. 1 over 2 pi d theta. Now think of this. ये या तो इसको कैलकुलेट कर लें, और इसको कैलकुलेट करेंगे तो आपके पास वही आंसर आएगा जो अभी हम डायरेक्टली लिखने लगे. So this is a cosine function. जिसको मैं एक पूरी साइकिल के ऊपर इंटीग्रेट कर रहा हूं. So this is like a cosine function जिसको पूरी साइकिल के ऊपर इंटीग्रेट कर दें. ये cosine फंक्शन है जो 0 से स्टार्ट होता है. ठीक है, इसको इंटीग्रेट करेंगे तो सी दिस एरिया हियर एंड दिस एरिया हियर दे कैंसिल आउट, सो आंसर शुड बी 0। ठीक है, लेकिन आप कह रहे हैं कि आप कहेंगे कि ये एक थीटा भी आ गया। वेल अगर थीटा आ भी गया तो नो बिग डील, तो मेरा जो 0 है वो यहाँ से स्टार्ट नहीं होगा, 0 जो है वो मेरा लेट्स से यहाँ से कहीं से स्टार्ट हो जाएगा। ठीक है, नाउ यू कंसीडर one complete cycle again, and one complete cycle here means कि ये जहां से ये स्टार्ट हुआ था इसी जगह पे यहाँ जाके now you add these areas together, जिनको अभी मैं ये हाईलाइट करने लगा हूं, this area plus this area plus this area, ये one complete cycle है, one complete cycle 2 pi duration की one complete cycle, you have time here one complete cycle। उसके ऊपर भी अगर करेंगे तो ये एरिया ऐड होके इस नेगेटिव एरिया के बराबर आ जाएंगे एंड यू विल गेट द आंसर एज 0। दिस इज द इंटीग्रल ऑफ अ कोसाइन ओवर वन साइकिल। अगर ऐसे नहीं देखना तो इसको इंटीग्रेट करें, कोसाइन का इंटीग्रल जो है वो साइन होता है, और देन यू विल पुट द वैल्यू 0 and 2 pi and you will see that the answer will turn out to be 0. Sin 2 pi is 0 and sin 0 is also 0. Okay, now mean is constant. What about the autocorrelation function Rx T1 T2? ठीक है, ऊपर हमने देखा था IID जो थे उनका ऑटोकोरिलेशन फंक्शन जो है वो भी कांस्टेंट आ गया था, ऑटोकोरिलेशन फंक्शन जो है वो कांस्टेंट आ गया था, दिस वन और दिस वन, एंड वाज अ फंक्शन ऑफ, कुड बी कंसीडर्ड एज फंक्शन ऑफ n1 minus n2, इसलिए वो Whitesand stationary था। Let's see if this guy is a Whitesand stationary or not. Okay. So let's find the autocorrelation function of this guy. And the autocorrelation function of this guy would be equal to, by the way, इसकी जो Cx T1 T2 है autocovariance function will also be the same. Why? Because the mean is 0. तो वो Rx T1 T2 में से means का product minus करते हैं. So this would be equal to, both of these guys would be equal to x of T1, x of T2. So what is x of T1? X of T1 a cosine omega d plus theta, and x of T2 is a cosine omega t2 plus theta. So इनकी expected value आपने find करनी है. Once again, xt1 is a function of theta, xt2 is also a function of theta. So product of xt1 and xt2 will be a function of theta, और उसकी expected value कैसे find करेंगे? बिल्कुल उसी तरह जैसे ये mean value, ये भी expected value है आपने ऊपर find की. So this will turn out to be equal to, once again, 1 over 2 pi integral 0 to 2 pi a square cosine omega t1 plus theta cosine omega t2 plus theta d theta, omega t2 plus theta d theta. इसमें कोसाइन की प्रोडक्ट्स वाला फॉर्मूला एक लगा सकते हैं कि कोसाइन x कोसाइन y, x और y नहीं यूज करते, not a good idea. Cosine capital A cosine capital B is equal to 1 over 2 cosine A plus B plus 1 over 2 cosine A minus B. Yeah, formula which we remember from high school or junior high school. So Rx T1 T2 would be equal to 1 over 2 pi इस a square को भी बाहर खींच लें, a square over 2 pi, and then you have integral of, इसको यहीं पे इंटेग्रल बना देते हैं, इंटेग्रल 0 से 2 pi 1 over 2 cosine omega t1 plus t2 theta plus cosine ये भी इंटेग्रल के अंदर ही है, A minus B. A minus B would be omega cosine omega T1 minus T2 d theta. A bit mistake here. Cosine omega T1 plus T2 plus 2 theta. Yeah. Now, once again, this guy cosine omega T1 plus T2 और उसके अंदर हमने एक shift डाल दी है. You have to integrate it over 0 to 2 pi. 0 to 2 pi. This answer again will turn out to be 0, and this answer will turn out to be a square over 2. इसका आंसर आपके पास 2 pi आ जाएगा, pi आ जाएगा cosine omega T1 minus T2. T1 minus T2. So this is your autocorrelation function. This is function of T1 minus T2, which implies that random phase sinusoid is wide sense stationary. Wide sense stationary. So last time we talked about the random walk process. Random walk process. Let me try to find out the mean and autocorrelation function of this process. Mean and ACF, autocorrelation function. ये निकालते हैं इसका. Random walk process. Let me just remind you कि random walk process क्या था. Random walk process ऐसे था कि xn is equal to I is equal to 1 to n zi, where zi was equal to +1 or -1 with certain probabilities. So let's say with probability 1 over 2, with probability 1 over 2. So at every step, this is the step process. At every step, you have either +1 or -1 with probability 1 over 2. और उन सबको आप add करते जाएं. उन सबको आप add करते जाएं, तो you will get xn. You will get xn. Okay. So after 50 steps, you would have added 50 of these guys together. So हमें पता नहीं है उस 50 में से कितने +1s होंगे, कितने -1 होंगे. But we can find the probabilities, and we found these probabilities previously in the last week. Okay. Let's try to find the mean of this guy. Okay. Expected value of xn. Mean निकालते हैं. Expected value of xn. Mean expected value is a linear function, so this would be summation of I is equal to 1 to n expected value of zi. So summation के अंदर चला जाएगा expected value of zi. What is the expected value of zi? The expected value of zi is, answer in the chat window. Expected value of zi. इसकी क्या expected value है? 0. Thank you, Haris. Thank you. So this would be 0. Expected value of xn is 0. Is this constant? Yes, this is constant. ये constant है. So देखते हैं random walk process जो है वो wide sense stationary है या नहीं है. Wide sense stationary है या नहीं. Let's try to find out. How many people think that random walk process is a wide sense stationary process? How many people think that random walk process is a wide sense stationary process? देखिए, जब आप random walk कर रहे हैं, so कभी हो सकता है कि at some point in time you are very close to the initial point. ऐसा भी हो सकता है ड्रिफ्ट कर करके बहुत दूर तक पहुंच जाए. ठीक है. So intuitively ऐसा लग रहा है कि शायद ये stationary process नहीं होगा. Intuitively ऐसा लग रहा है. But let's try to find out. Mohammad Abdullah, you have a question? Please go ahead and ask.
सर ऊपर जो हमने फाइंड किया है पिछली वाली एग्जांपल में rx t1 t2 वो our resulting function is cos of t1 minus t2, so is it not, so it's a function of cos of t1 minus t2, it's not a direct function of t1 minus t2?
It is a function of t1 minus t2.
Okay.
It is a function of t1 minus t2. इसके अंदर t1 minus t2 के अलावा t1 और t2 कहीं और अपीयर नहीं हो रहा. जब भी t1 t2 अपीयर हो रहे हैं वो t1 minus t2 की शक्ल में अपीयर हो रहे हैं. So it is a function of t1 minus t2. e power t1 minus t2 क्या वो function of t1 minus t2 नहीं होगा? e power t1 minus t2. It is a function of t1 minus t2. Okay. All right, so let's try to find the autocorrelation function of x n rx n1 n2, which is expected value of x n1 x n2. So assume करते हैं n2 is greater than n1. ये assume करते हैं. ये assumption हम relax कर देंगे बाद में, लेकिन अभी for solving this let's just assume that. So how do I find this out? ये इतना आसान नहीं है मालूम करना unless we use this trick, and this trick makes it very simple. So this is expected value of xn1 और xn2 के साथ मैं ये करता हूं कि xn2 minus xn1 plus xn1 ऐसे कर देते हैं. कोई इतराज नहीं, कोई didn't change anything. एक सब्ट्रैक्ट किया और एक ऐड कर दिया उसमें. लेकिन इससे फायदा ये हो गया कि now I can write this as expected value of xn1 square plus expected value of xn1 into xn2 minus xn1. Okay, ऐसे लिख सकते हैं. ये करने से फायदा क्या हुआ? ये करने से फायदा ये हुआ कि this guy here, इसको मैं लिख सकता हूं, this can be written as expected value of xn1 square, ये तो ऐसे ही आ जाएगा, plus expected value of xn1 multiplied by expected value of xn2 minus xn1. I can only write this when these two guys, xn2 minus xn1, this guy here, इसको रेड से कर देते हैं, this guy here and this guy here, when these two guys are independent. Or my claim is that they are independent. Why? Anyone can answer that? Why these two are independent? दो रैंडम वेरिएबल की प्रोडक्ट की एक्सपेक्टेड वैल्यू लेनी हो तो उसको एक्सपेक्टेड वैल्यूज की प्रोडक्ट्स के शक्ल में मैं सिर्फ लिख सकता हूं उस वक्त when the two random variables are independent. Remember, हम expected value of x y, in general it is not equal to expected value of x, expected value of y, unless x and y are independent. If x y independent, ये सिर्फ उस सूरत में होते हैं. लेकिन मैंने तो ये वाली इक्वेशन को जो है ऐसे करके लिख दिया. क्यों लिख दिया? Anyone can answer this? कोई आंसर कर सकते हैं? Because we showed last time कि random walk is an independent increment process. ये जो हमने ऊपर यहाँ पे भी बनाया था कि random walk is an independent increment process. Oops. Random walk is a subset of independent increment process. और independent increment process का मतलब ये है कि कोई से दो टाइम्स ले लें. अगर ये नॉन ओवरलैपिंग है n2 minus n1 two non-overlapping times, and this is xn1 minus maybe x0. आप 0 से अगर start करते हैं तो so these two are non-overlapping ranges of time. They will be independent. इनके दरमियान जो random process होगा वो independent होगा, non-overlapping periods of time. ठीक है? Independent increment property. यहाँ पे हमने क्या चीज लगाई है? Independent increment property. And this property was proved last time. So what that means is that your Rx n1 and 2 will turn out to be equal to expected value of xn1 square. Simply. क्यों? क्योंकि expected value of xn1 ये तो हमने शो कर दिया है कि ये 0 है. xn को ही हमने 0 शो कर दिया है तो xn1 भी 0 होगी, xn2 भी 0 होगी, तो ये तो 0 हमने शो कर दी. So this is equal to expected value of xn1 square. And what is xn1 square? Expected value of xn1 square is summation I is equal to 1 to n1 zi. ये तो डेफिनेशन है, ये तो रैंडम वॉक की डेफिनेशन है, xn nth टाइम तक all the zi's accumulated together, तो n1 टाइम तक कितने zi's accumulate करेंगे, up to n1 zi's को accumulate कर लेंगे, and then the square here, ठीक है. So this would be equal to expected value of I is equal to 1 to n1 summation of j is equal to 1 to n1 zi zj zi zj, ठीक है. ये हमने स्क्वायर समेशन को स्क्वायर ऐसे करते हैं, समेशन को हम स्क्वायर ऐसे ही करते हैं. हाउ मेनी टर्म्स हियर, जिसमें ये zi zj आ रहे होंगे, टोटल एक समेशन में n1 टर्म्स हैं और वो समेशन दूसरी समेशन के अंदर है, तो एक और n1 टर्म्स उसके ऊपर आ रही हैं. सो दिस इज n1 स्क्वायर टर्म्स, n1 मल्टीप्लाइड बाय n1 टर्म्स. सो ऑल ऑफ दोज n1 स्क्वायर टर्म्स, उन सब के सब के अंदर सिर्फ n1 टर्म्स ऐसी हैं when I is equal to j, when I is equal to j. When I is not equal to j, expected value of zi zj would be equal to expected value of zi into expected value of zj, क्योंकि ये z's जो हैं ये सारे इंडिपेंडेंट थे, ये तो रैंडम स्टेप के थे. zi is equal to zj is equal to 0 when I is not equal to j. Whenever I is not equal to j, then expected value of zi zj would be equal to 0. So this would be equal to expected value of सिर्फ वो n1 टर्म्स ऐसी होंगी जहां पे zi और zj बराबर हो जाएंगे, तो वहां पे हम zi स्क्वायर कर देंगे, zi into zi. So this would be equal to summation I is equal to 1 to n1 expected value of zi square. अब remember zi क्या था, zi was +1 with probability 1/2 -1 with probability 1/2, वो निकालना कोई आसान काम है. I is equal to 1 to n1 expected value of zi square is +1 with probability 1/2 plus -1 square into probability 1/2. ये स्क्वायर करना जरूरी है, क्योंकि zi square. So this would be equal to, इसका क्या आंसर आएगा? So this is summation I is equal to 1 to n1 1. Let's say it. So this is equal to n1. So यहां से हमें क्या पता चला कि if n2 is greater than n1, तो इसका हमारे पास आंसर आ गया है n1. So Rx n1 n2, तो जो भी उनमें से मिनिमम होगा n1 n2 जो भी मिन होगा वो आंसर आ जाएगा उसका. If n1 is greater than n2, तो इसका आंसर n2 आ जाएगा. अगर n2 greater than n1 है तो इसका आंसर n1 आ गया. Now variance of xn is Rx n1 n2, और n2 की जगह पे भी हम n1 ही कर देंगे, n1 minus mx n1 multiplied by mx n1. So ये variance of x n1 हम निकाल रहे हैं. So let's see कि what would be Rx n1 n1. This is just n1, क्योंकि अभी हमने बताया, और means जो है वो 0 हो जाएंगे. So variance of x n1 is equal to x n1. Variance of x n2 क्या होगी, is n2. Same? No. So not wide sense stationary. This can also be seen कि autocorrelation function, which is min of n1 minus n2, is not a function of n1 minus n2. Okay. So this is great. ये हमने कुछ examples करनी जिसमें mean autocorrelation function find किए. We will see few more examples जिसमें we will find the mean autocorrelation function. I'm going to switch gears and jump to what we call a Poisson process. We have already seen the Poisson random variable. Poisson process is when you stick the time in. When you stick the time in. Poisson random variable क्या था? Poisson random variable था कि typos in a book बहुत कम होते हैं typos in a book. Okay? So it was used as an approximation for binomial random variable when you have many trials. When you have many trials, each trial being successful with some probability, and that probability is small. Many trials, कुछ trials उसमें से probability of success उनकी small है. कितनी successes होंगी आपके पास? And successes here is typos in the book. एक typo आ गया तो एक success है, दूसरा typo दूसरी success है. So typically you don't have too many typos in a book. बहुत ज़्यादा नहीं होती. So Poisson process में the probability of occurrence of a typo or occurrence of that event is very small. Small p, large n for binomial. Small p and large n for binomial. वो हमारा Poisson random variable था. So what is a Poisson process? जिस तरह हमने random variable को extend करके हमने random process बना दिया. It's a indexed collection of random variables. Indexed collection of random variables. So again, Poisson process is indexed collection of Poisson random variables, but in a slightly different way. So इसकी definition बता देते हैं आपको. So Poisson process is, we have a process as a Poisson process which satisfies the following. कि number of events, और ये events क्या हो सकते हैं? कि arrivals of customers in a bank, arrivals of customers in a PDC line, arrival of packets in a computer network, data packets in a computer network, or meteors striking the earth. उनको हम टाइम के साथ इंडेक्स कर देंगे. Number of events accumulated in an interval of duration t. In an interval of duration t. ठीक है, इसको ऐसे भी लिख सकते हैं, in an interval of duration t. ऐसा भी हो सकता है कि आप 5 से 5 plus t तक जितने आएंगे वो नंबर जो है वो आपके पास Poisson random variable होगा. वो Poisson random variable होगा. is Poisson lambda t. is Poisson lambda t. ये जो number of events accumulated in an interval of duration t is Poisson lambda t. इससे एक inference हम ये भी निकाल सकते हैं. This means number of events until time t, starting from 0 until time t, 0 से लेके t तक, is also Poisson lambda t. 50 और 50 plus t के बीच में कितने आएंगे? वो भी Poisson lambda t. 100 plus t के बीच में कितने आएंगे? वो भी Poisson lambda t. 100 और 100 plus x के बीच में कितने आएंगे? वो होगा Poisson x. Poisson lambda x. So this is a continuous time process. Continuous time compared to a discrete time process. This is a continuous time process. Is this a discrete alphabet process or continuous alphabet process? Answers in the chat window. Discrete alphabet or continuous alphabet? कोई दे सकता है जवाब? The process is the number of events accumulated. Is this discrete or continuous? It's discrete. Discrete alphabet. Okay. And lambda is called the rate of the process. ये जो lambda है इसको process का rate कहते हैं. So definition इसकी क्या हो गई हमारे पास? Definition इसकी ये कि x of 0 is 0. ठीक है? x of t is independent increment process. That is, if it is independent increment, that means कि ये Markov भी होगा, क्योंकि all independent increment processes are Markov processes. Okay? And the third is, first, second, and third is okay, the number of events in any interval t, number of events in any, या events कह दें या arrivals कह दें, or arrivals in any interval t, in any interval t is Poisson lambda times t. Poisson lambda times t. That also means that this guy has stationary increments. This guy has stationary increments. इसकी एक भी एग्जांपल आपको देंगे stationary increments का क्या मतलब है. Independent increments का मतलब है कि the incremental value is independent of the previous increments. Stationary increments का मतलब है कि same time duration के बीच में same arrivals होंगी, और वो हमें पता ही है, since it is Poisson lambda, so उसका जो mean होगा Poisson lambda का, for duration 1 would always be same. कुछ examples इसकी करते हैं, but before that I'm going to just specify the following as well. तो इसको भी highlight कर देते हैं. For any times s and t greater than or equal to 0, s is greater than 0, t is greater than 0, s एक time है और t एक time है. So what this guy is saying is probability x of t plus s minus x of s. This is the number of arrivals. S से लेके t तक जो आनी है. So ये अगर आपका टाइम चलता जा रहा है, so ये आपके पास s है और ये आपके पास t plus s है. तो दरम्यान में ड्यूरेशन कितनी हो गई? ड्यूरेशन आपके पास हो गई t. ठीक है, ड्यूरेशन हो गई t, और इस t के अंदर कितनी अराइवल्स होंगी? वो Poisson lambda t अराइवल्स होंगी. So this guy, the probability that this guy is equal to n, जो उसका PMF है, is equal to Poisson lambda t, which is e to the minus lambda t power n divided by n factorial. For n is equal to 0, 1, ... 2, 3, 4, 5. So distribution of x of t, ये क्या होगी? So the probability x of t is equal to k, some constant k is equal to, so this is x of t is equal to k का मतलब ये है कि एक ड्यूरेशन t है, 0 से स्टार्ट करके आप t तक गए, उस ड्यूरेशन t के अंदर k अराइवल्स हैं, that should be Poisson lambda t. So what is the Poisson lambda t random variable taking a value equal to k is e to the power minus lambda t power k over k factorial. And what is the x of t2 minus x of t1? इसकी क्या डिस्ट्रीब्यूशन है? इसकी डिस्ट्रीब्यूशन क्या होगी? सो ये देखें, ये x of t2 minus x of t1, तो ड्यूरेशन कितनी है आपके पास? t2 minus t1. So distribution here is Poisson lambda t2 minus t1. So this property also means that we have independent increments and stationary increments. Yeah. Now, इसकी एक आपको pictorial view आपको दे देते हैं कि let's say you start at, ये आपके पास जो है टाइम है time t, so this is t is equal to 0. So let's say you have first arrival here, second arrival here, third arrival here, and fourth arrival here, and so on and so forth. Okay. So this is your first arrival, this is second arrival, this is third arrival, and this is fourth arrival. So the time here until the first arrival, this is T1. सेकेंड अराइवल के लिए जितना टाइम चाहिए वो आपके पास है T2. थर्ड अराइवल के लिए जितना टाइम चाहिए वो है T3. फोर्थ अराइवल के लिए जितना टाइम चाहिए वो है T4, and so on and so forth. Now we talk about the waiting times. This is the inter arrival times, T4, T3. All of these are called inter arrival times. ये हमने जब पोसॉन रैंडम वेरिएबल पढ़ रहे थे तो हमने कुछ इसका जिक्र किया था इंटर अराइवल टाइम का. इसकी डिस्ट्रीब्यूशन क्या होगी? t is equal to 0 पे आपने स्टार्ट किया, पोसॉन अराइवल्स हैं, टाइम अंटिल द फर्स्ट अराइवल, दिस वुड बी एन एक्सपोनेंशियल रैंडम वेरिएबल. ये हम शो कर सकते हैं, प्रूव कर सकते हैं, अभी कर भी देंगे. हमने पहले भी किया था ये हमने पहले भी किया था, एंड वी विल प्रूव इट अगेन दैट दिस टाइम t1 is an exponential random variable. Time until the first arrival. This time T2 after the first arrival until the second arrival. This would also be an exponential random variable. And this would be an exponential random variable with parameter lambda. Okay. Now we talk about waiting times. So this time until the first arrival is the waiting time for the first guy. Time until the second arrival starting from the first is the waiting time for the second arrival. So you can see कि ये आपके पास ये W3 है, waiting times. These are the waiting times. We can clearly see कि waiting time for the first guy is the same as the inter-arrival time for the first guy. Waiting time for 2 is equal to T1 plus T2, and W3 is equal to T1 plus T2 plus T3, and so on, etc. इनको वेटिंग टाइम्स बोलते हैं और टीज को जो है वो इंटर अराइवल टाइम्स बोलते हैं. दिस इज द स्टैंडर्ड टर्मिनोलॉजी which is used. Okay, standard terminology. Time for an example. Let's say you have a random process which is Poisson 10t, and t is a random process, is a Poisson random process. T is in seconds. T hours में भी हो सकता है, days में भी हो सकता है, light years में भी हो सकता है. ठीक है? So in this problem, assume T is in seconds. Okay. So first of all, probability, we need to find the probability that first arrival is not until 5 seconds. What that means is कि आपका टाइम चलना शुरू हुआ 0 से and 5 seconds पे जाके पहली अराइवल हुई है. Not until 5 seconds, इसके बाद कभी होगी अराइवल. 5 seconds तक आपकी कोई अराइवल नहीं. This probability that the first arrival is not until 5 seconds, इसका मतलब है कि probability your time T1 for the first arrival, this time T1 until the first arrival is not until 5 seconds. इसका मतलब 5 के बाद है. So this means this is greater than or equal to 5. Everyone is agreed with that? T1 is greater than equal to 5. But that also means कि this is the same as the probability कि पहले 5 सेकंड के अंदर तो कोई अराइवल नहीं हुई. X of 5, which is the number of arrivals in the first 5 seconds, X of 5 is 0. But what is the distribution of X of 5? X of 5 की distribution ये हमने निकाली थी. X of t is equal to k is simply a Poisson random distribution. Poisson random variable की distribution, because X of 5 is a Poisson random variable with parameter 5t, with parameter 5. Okay, with parameter 5. Well, actually not parameter 5, with parameter 10 times 5, because this is 10 times t. So this is equal to e to the minus 10 lambda t which is this 10 times 5, 10, 5, 0 over 0 factorial. So this is e to the minus 50, e to the minus 50. बहुत ही थोड़ी probability है, बहुत थोड़ी probability. Second, same problem. Probability of 15 arrivals in within first second, पहले सेकंड के अंदर 15 अराइवल्स होते हैं. इसका क्या मतलब है कि probability that the waiting time for the 15th arrival is less than equal to 1, एक सेकंड के अंदर, विद इन फर्स्ट सेकंड के अंदर 15 अराइवल्स आपके पास हो जाए. इसका मतलब है कि वेटिंग टाइम फॉर द 15th guy is less than equal to 1. Okay? What that also means is same as the probability that x of 1 is equal to 1 पे जो आपकी कितनी अराइवल्स हो चुकी हैं वो 15 अराइवल्स हो चुकी हैं. विद इन फर्स्ट सेकंड आपकी 15 अराइवल्स हो चुकी हैं. अगेन इसकी डिस्ट्रीब्यूशन कैसे निकालेंगे? So this is e to the minus lambda, which is 10 times 1. 10 times 1 power 15 over 15 factorial, which turns out to be 0.035. So I'm going to ask a question that everyone should be able to answer immediately by looking at the answer to first question about this. So what is the probability of no arrival between 90 to 95 seconds? Answers in the chat window. The probability of no arrival between 90 to 95 seconds. This would be e to the minus 50. क्यों? क्योंकि हमने पोसॉन प्रोसेस डिफाइन ही ऐसे किया कि एक इंटरवल टी के अंदर जितनी अराइवल्स होती हैं वो पोसॉन डिस्ट्रीब्यूशन है. तो जो डिस्ट्रीब्यूशन x5 की थी हमारे पास वही डिस्ट्रीब्यूशन x95 माइनस x90 की होगी. सो 90 से 95 के बीच में 5 सेकेंड्स गुजर गए हैं और 0 और 5 के बीच में भी 5 सेकेंड्स गुजर गए हैं. सो दैट मीन्स कि दोनों एक ही पोसॉन रैंडम वेरिएबल्स होंगे, इंडिपेंडेंट बट identically distributed. So also e to the minus 50. So I'm going to ask this question. What is the probability? Now this is going to be an interesting question. What is the probability that x10 is equal to 100? यानी 10 सेकंड पे आपने देखा तो आपके पास 100 अराइवल्स हो चुकी थी. Given that x5 is equal to 25. ये conditional probability है. If I remove this conditional part, everyone can answer this question. What is the probability x10 is equal to 100? वो आपको पता है कि this is Poisson lambda t, and t is 10 here. T is 10 here, and lambda is also 10. So lambda is 10. Lambda is 10 here. So this is Poisson with the parameter, Poisson random variable with the parameter 10 times 10, which is 100. lambda जो इसका होगा, lambda times t जो है वो 100 होगा. So Poisson lambda t, वो parameter से this would be a Poisson random variable. You can find Poisson x0, x10 taking a value of 100. But we are asking a slightly different question. We have told you यहाँ से time चलता जा रहा है. So let's say you have 5 here and 10 here. So अगर मैं आपसे कहूं कि what is the probability कि you have 100 arrivals here, ठीक है? This will have some probability. This is not the probability that we are asking. The probability we are asking is कि this information is given to you. कि पहले 5 सेकंड में x of 5 was 25. Okay? Was 25. I am asking what is the probability given this 25 value information, what is the probability that you have 100 arrivals given this information? So this information is collective कि ये 10 तक आपके पास 100 अराइवल्स हो. What that really means is कि हम in fact the real question that we are asking is what is the probability that 5 से लेके 10 तक you have 75 arrivals. That is the real question. That is the real question. Intuitively हमें यही भी लग रहा है कि this is probability x5 is equal to 75. यानी 5 सेकंड के अंदर आपकी 75 arrivals. And this can easily be found. This is e to the power minus 50, 50 power 75 over 75 factorial. ये फाइंड आउट कर सकते हैं. इसको मैथमेटिकली भी सॉल्व करते हैं. कि probability x10 is equal to 100. Probability x10 is equal to 100 given x5 is equal to 25. Remember that x10 is a random variable. x5 is also a random variable. So you are looking at the random process at 10, you are looking at the random process at 5. So ये दो random variable and this is a simple conditional probability. One random variable takes the value 100, given that the other random variable takes the value 25. So this is probability of A given B. So simply x of 10 is equal to 100, comma, which means and x of 5 taking value 25 divided by probability x of 5 taking value 25. ये तो ऐसा लग नहीं रहा कि ये यही वाला आंसर आएगा, but let's take a look. देखते हैं. So this would be equal to x10 को हमने 100 करना है and x5 को 25 करना है. So that means I can simply write this x of 10 minus x of 5 is equal to 75 divided by probability of x5 is equal to 25. In fact, इसको अगर ज्यादा थोड़ा एक्सपेंड करके लिखना चाहें, we will drop that anyhow. x of 5 is equal to 25. ये इंफॉर्मेशन अगर डाल भी दें तो ये redundant information है. This information is redundant. So x10 is given 100, x5 is given 25. So x10 minus x5 should be 75 and x5 is equal to 25. Now you can see that this guy and this guy, these two will be independent. Why? Because this is an independent increment process. तो मैं इसको वैसे ही निकाल सकता हूँ. और वैसे भी हमें यहाँ पे पता चल रहा है कि x10 is equal to 100, x5 is equal to 25 really means कि probability of x10 minus x5 is equal to x10 minus x5 is equal to 75 divided by probability x5 is equal to 25. Into the probability x5 is equal to 25. Yeah, I think we should not be able to drop this until we separate this out. क्योंकि अगर हम x5 is equal to 25 नहीं बीच में डालेंगे तो हम शायद कुछ information यहाँ पे lose कर लें. So this has to be here. But these two are independent. These two guys are independent. So we can, this guy and this guy are independent because of the independent increments. So I can separate these out. Once you separate this out, now this guy will cancel with this guy. So this will turn out to be probability x10 minus x5 is equal to 75, which is equal to now because of the stationary increments and the definition of the Poisson process, ये एक interval है 5 units का, probability 5 units का जो interval है उसके अंदर आपके पास 75 arrivals, which is the same as this guy. e power minus 50 into 50 power 75 over 75 factorial. So let me ask the flip question. Flip question पूछते हैं. Flip question पूछते हैं यहाँ पे. यहाँ तो हमने ये आपको बताया था कि 25 arrivals until 5. What is the probability of additional 75 arrivals until 10? Additional 75 arrivals in the next 5 seconds. Now I'm going to ask you a flip question. The flip question is कि आपके पास ये time है. This is 5 and this is 10. 0 से start होता है. Now you are given कि 100 arrivals हैं यहाँ पे. You are given कि 100 arrivals हैं. And being asked कि probability of 25 arrivals in this time. So अब ये पूरा आपको गिवन है और इसकी probability पूछ रहे हैं. Previously आपको ये छोटे वाले में दिया हुआ था और additional 5 सेकंड के अंदर 75 के arrivals पूछ रहे थे, which was easy to find. यहाँ पे अब आपको सारे टाइम को बता दिया. कुछ पता नहीं है कि 100 arrivals जो है ये शुरू के 5 सेकंड में है या आखिर के, इसमें से कितने arrivals जो है वो शुरू में आते हैं. But we do know that there are 100 arrivals here and I am interested in 25 arrivals in the first 5 seconds. Now, intuitively, if you look at it, कि आपको 100 successes मिल रही हैं from 0 to 10. 100 successes. I'm interested in the number of successes to be 25 in the first 5 seconds. कुछ ऐसा लगता है कि शायद binomial आएगा. कुछ ऐसा लगता है binomial आएगा. Let's try to figure out. ठीक है. So we are being asked the probability x5 is equal to 25 given x10 is equal to 100. ये वही probability है, सिर्फ flip कर दिया इसको. ये probability आपने find out कर दी. So this would be equal to the probability x5 is equal to 25 and x10 is equal to 100 divided by the probability x10 is equal to 100. x10 is equal to 100. So this would be equal to the probability, बिल्कुल उसी तरह जैसे पहले किया था कि x5 तो 25 है आपके पास, and since we know that x5 is 25, so I can write x10 minus x5 is equal to 100 minus 25, which is 75, divided by probability x10 is equal to 100. x10 is equal to 100. So this would be equal to, now again, independent increments. So this would be equal to probability x5 is equal to 25 into probability of x10 minus x5, which is again x5 is equal to 75, okay, divided by the probability x10 is equal to 100. Now you might notice कि जहां या ऊपर जो कैंसिल हो गया था यहाँ पे ये कैंसिल नहीं हो रहा, because now this guy is x5 and this guy is x10. ये नहीं अब कैंसिल हो सकते, क्योंकि ये कैंसिल नहीं हो सकते. So these are still Poisson random variables. These still are Poisson random variables. इनकी probability हम easily find कर सकते हैं. कैसे? x5 means lambda t, which is lambda is 10. Don't forget that lambda is 10. So ये आपके पास Poisson 50 आपके पास आ जाएगा. Poisson 50, Poisson lambda t, Poisson 50. Poisson 50 होगा. So this would be e to the minus 50 into 50 power 25 over 25 factorial. ये सिर्फ अभी ऊपर वाली टर्म का आया है इसका. Multiplied by x5 is equal to 75 is e to the power minus 50 power 75 over 75 factorial. इसी तरह ये नीचे denominator में what we have is e to the power minus 100 power 100 over 100 factorial. ये 3 पोसॉन्स आपके पास आ गए। तो काफी सारी चीजें इसमें से कैंसिल हो जाएंगी। कौन सी चीजें कैंसिल होंगी? So this guy will cancel out, this guy will cancel out with this guy, e power minus 100, और ये आपके साथ कैंसिल हो जाएंगे। सो और आपके पास क्या बचेगा? और आपके पास बचेगा 100 फैक्टोरियल ऊपर आ जाएगा, 25 फैक्टोरियल हियर, 75 फैक्टोरियल हियर, इनटू 50 पावर 100 over 100 power 100. Aha. So this is 100 choose 25, 100 choose 25, 1 over 2 power 100. Looks like binomial to me. Looks like binomial to me. With probability equal P 1 by 2. So in general, if you have 2 times s less than equal to t, ये आपके पास times है, and k less than equal to n, then we can write the following. Number 1, probability of x of t is equal to n given x of s is equal to k. x of s is less than t. तो आपको x of s is equal to k पहले से दिया हुआ है, x of t is equal to n. So इसका मतलब है कि additional t minus s में आपके पास n minus k आ जाए. So n minus k arrivals in additional t minus s seconds. T minus s units of time. Seconds के बजाय units of time. Time units. Yeah. Which is equal to lambda t minus s, lambda t power n minus k e to the minus lambda t minus s divided by n minus k factorial. This is one, and the other is probability that x of s is equal to k given x of t is equal to n. So t is greater than s, t is greater than equal to s. तो आपको टोटल का गिवन है और अब आपसे पूछ रहे हैं कि उसके कुछ फ्रैक्शन ऑफ टाइम s which is smaller fraction of time, उसके अंदर आपके पास smaller number of arrivals हो k which is a smaller number of arrivals here. ठीक है? So this would be equal to n choose k s over t power k 1 minus s over t power n minus k. Okay. So mean and ACF of Poisson random process. Mean and ACF of the Poisson random process. So what is the mean x of t? X of t we know is a Poisson random variable. Is a Poisson random variable is Poisson lambda t. Is the mean of the Poisson lambda t, which is equal to lambda t. It's lambda t. Okay. Is this constant? Not constant. Not constant. Which means कि ये process stationary, wide sense stationary तो हो ही नहीं सकता. Not wide sense stationary. ये हो ही नहीं सकता. What about Rx T1 T2? It's a continuous time process, so this would be equal to expected value of xt1 xt2. वही जो हमने ट्रिक लगाई थी रैंडम वॉक प्रोसेस के अंदर, वही ट्रिक यहाँ पे लगाएंगे. So this will turn out to be equal to lambda times min of T1 T2. Solve. इसको सॉल्व करेंगे. 3-4 स्टेप्स हैं इसके बीच में, बट इट कैन इजीली बी सॉल्व. नोट्स में ये सॉल्व किया हुआ है एंड वी हैव अपलोडेड द नोट्स. एक कुछ अपडेटेड नोट्स जो है वो मे बी लेटर टुडे और टुमारो वी विल अपलोड द अपडेटेड नोट्स. नाउ Poisson inter-arrival times and waiting times. तो ये हमने पहले बताया था कि इंटर अराइवल टाइम्स T1, T2 dot 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 are exponential lambda IID. So ये अगर आपके पास arrivals हैं, so this is t is equal to 0. ये पहली अराइवल है, फिर उसके बाद एक और अराइवल है, फिर एक और अराइवल है, फिर एक और अराइवल है. So this time is exponential lambda. This time is also exponential lambda. This time is also exponential lambda. Okay, is exponential lambda. We can prove this. We can prove this. कैसे? T1 के लिए शो करते हैं. So probability T1 is greater than T. T1 is greater than T is the same as the probability कि T1 is greater than T का मतलब ये है कि पहले T के अंदर कोई अराइवल्स नहीं होंगे, यानी वेटिंग टाइम, arrival time for the first guy, inter arrival time for the first guy is greater than T means x of T is 0. X of T is 0, which is equal to, and x of T is a Poisson lambda T random variable, which is equal to e to the power minus lambda t power 0 over 0 factorial, lambda t power 0 over 0 factorial, which is equal to e to the minus lambda t, which means that probability T1 is less than equal to T is equal to 1 minus e to the minus lambda t. What is this guy? This is the CDF of exponential lambda. Or CDF uniquely identifies the distribution. इसका क्या मतलब है कि T1 is exponential lambda. इसी तरह से शो कर सकते हैं T2 को भी एक्सपोनेंशियल लैम्डा है, और T2 और T1 की इंडिपेंडेंस भी शो कर सकते हैं कि ये आइडेंटिकली डिस्ट्रीब्यूटेड तो हैं, ये इंडिपेंडेंट भी हैं. नाउ वेटिंग टाइम्स ये हमने पहले शो किया है. वेटिंग टाइम्स W1 is equal to T1. पहले के लिए जितना वेट करना है वो इंटर अराइवल टाइम T1 है, so is exponential lambda. W2 is equal to T1 plus T2. What is this guy? Exponential lambda plus exponential lambda. Now, what is the sum of two exponentials? Sum of two exponentials is दो के लिए जो वेट करना पड़ता है. It's a gamma random variable. So Wn, which is equal to summation I is equal to 1 to n Ti, is basically a gamma random variable with parameters n and lambda. And this again can be proved. This is something that we had proved a long time ago when we were talking about the Poisson and gamma random variables. ये हमने उस वक्त शो भी किया था, एक्सपोनेंशियल और gamma के बारे में जब डिस्कशन हुई थी. So we had shown this as well. This will be shown in the notes as well. अभी जो currently version of notes है उसके अंदर हमने सिर्फ वो result पुराने उनसे कॉपी किए, but we will have an explanation for this as well. So next class we will try to finish the discussion on the random processes. We'll talk about the Gaussian random processes, and if anyone has heard of Brownian motion, water molecules जो होते हैं पानी के अंदर जो है वो they move around in a Brownian, can be modeled as moving as a Brownian motion. So it's a Gaussian, can be derived from a Gaussian random process. So we'll talk about the Gaussian random process and Brownian motion, and we will also talk about Gauss-Markov processes. Okay. So we will do that on Friday. This is it for today. If there are any questions, I will be happy to answer. We'll stay here, and otherwise we will close the session. Any questions so far? Gigi?
Sir, is there a difference between random process and stochastic process, or are they same?
Same thing.
Okay, sir.
Exactly same thing. Any other question? किसी और का question? No? So I'll stop the share and then close the session. We'll upload the video as soon as it is available. Thank you so much for showing up this morning.